Okay, students, I am very much happy that to teach this wonderful problem, that is sequencing problem. Okay, right. So far we studied about the problem of two machine and n jobs. Two machine and n jobs. Now I am taking in another problem. Suppose three machines are there, and n jobs are there. Three machines are there and n jobs are there. Okay. So if that is the case, how to do this problem? How to do this particular problem? Okay. That's what our aim. There is three machines, n jobs. The previous cases, only two machines, n jobs. Okay. Right. How to do that? I will discuss now. The first step is that the minimum in the first machine we have to take. Okay. So before going into the problem, let us discuss about this. There are 1, 2, 3, 4, 5, 6 jobs are there, and three machines are there. One is turning machine, threading machine, and curling machine. M1 is turning machine, M2 is threading machine, and M3 is curling machine. And here jobs, one. Okay, what happened? Here jobs 1, 2, 3, 4, 5, 6. The red color inside the boxes are the machine times. The machine times are given inside this particular box in the red colors. Okay. Take for example M2, the threading machine. To do the fifth job, it takes 8 days. And M3, curling machine, it takes 13 days to finish the first job, like that. Okay. You understand the whole problem. Now let us go to solve the problem now. Okay. Now what is step number 1? Step number 1. The minimum in first M1 machine we have to find out. The minimum processing time in the first machine we have to identify first. Here 3, 12, 5, 2, 9, 11. So 2 is the minimum time or minimum days. Now we have to come to the last machine. In the last machine, what is the least time taking? We have to identify. That's what, yes, 8 is the minimum time taking. Okay, that we have to note. That is what M3 is equal to 8 days. Now, next is, we have to find out the maximum in the M2, the threading machine. What is the maximum? We have to find out. 8, 6, 4, 6, 8. So, 8 is the maximum processing time by this machine on these jobs. Okay, so that also we have to note. I repeat, step number 1 is to find out the least time taking in the first machine and least time taking in the last machine. Okay, now next is the maximum time taking in the second machine. That also we have to note. That is 8 days. Right. Now step number 2 is that we have to check up whether the minimum time of M1 is greater than or equal to M2. Minimum time of M1 is greater than or equal to M2, or minimum time of M3 is greater than or equal to M2. Minimum time of M3 is greater than or equal to maximum time of M2. So these two we have to check up. If these two are satisfied or any one of them are satisfied, okay, if these two are satisfied or any one of these condition is satisfied, okay, then we have reached our optimum stage. We have reached our optimum stage. Okay, right. So in this case, M1 minimum time is 2, M2 minimum time is 8 days. M3 minimum time is 8 days, M2 maximum time is 8 days. So second one is satisfied. So our condition is satisfied. Optimum is reached here. Now coming to the third step, third step, we are reducing the 3 machine time into 2 machine time. Here 3 machines are there, M1, M2, M3, turning, threading and curling. That 3 machine time that's changing into 2 machine time. How? M1 plus M2, M1 plus M2, that is what the first machine time I am taking as G1. So here 3 plus 8, 11, here 12 plus 6, 18, 5 plus 4, 9, and 4 plus, here 2 plus 6, 8, 9 plus 8, 17, and 11 plus 1, 12. Okay, this is what first machine we are assuming, and that processing time by adding the first machine and second machine processing time. We are adding. And the second one is that, here I forgot right there, second one is that M2 plus M3, okay, M2 plus M3. This is second machine time, okay. This is what? The second machine time we said. This is second machine time. How I am getting that? You will close it. Okay, now it's okay now. Now look at this, M2 plus M3, that is adding the machine time of M2 and M3. Adding the machine time of M2 and M3, 8 plus 13, 21, 6 plus 14, 20, 4 plus 9, 13, 6 plus 12, 18, 8 plus 8, 16, and 1 plus 13, 14. And this is the way we are getting the second machine processing time. This is the way we are getting first machine processing time. Okay, right, this is the way we can reduce the 3 machines into 2 machine times. Okay, so once you finish this, then other steps are we have done in 2 by n method type. Okay, 2 by n method, we know that 2 machine M, 2 machine, 2 machine n job, we know 2 machine m job, we know. So the same steps we have to go further. Okay, so let me find out the minimum processing time and maximum processing time there. Okay, now optimal sequence, semicolon. We know already what is an optimal sequence. Optimal sequence we have done no, semicolon. So we are taking the least processing time in these 2 machines. That comes 8. So 8 is the minimum processing time. Straight to that, job 4. Okay, corresponding to that, G1 is there. So 4th, the first machine, you have to fill up here. So this is over. Next release time is what? This one, 9 days. This 9 days falls in the first machine and third job. So third job, first machine, we have to, that is left hand side corner, we have to fill up. We have to fill up in here. And then what? That is over, this is over. Then next one is 11 days. Okay. So 11 days is the processing time by G1, the first job. So we have to write in the left hand side. Okay. Right. Next one is what? 12. Where's that? The left hand side we have to fill out. So this is what? 6. Then after release time, 18 days. So that we have to write in the left hand side corner. 2 we are writing here. And the last one is 5, the 16 days. And that we have to write here 5. Okay, 5. The next is 5, that's right hand side we have to fill up, and we are getting the optimal sequence like this. Okay, so this is the way we can make an optimal sequence for the given problem. Now, let us calculate. I have to minimize the screen, then only it is easy for us to calculate here. Okay, yes, very nice. Now we know already that the optimal sequence we have right here 4 3 1 6 2 5, right? Then here turning time, in time, out time, threading machine, in time, out time, curling machine, in time, out time, ideal time for the three machines M1, M2, M3, turning, threading, curling. Now we know that already here the first starting time of the turning machine 0, so 4. Now we have to let it be bring down so that we can easily see that particular screen there. Okay, right. Now look at this 0, 4. Which machine? Turning machine. The turning machine, you have to go for turning machine. Okay, so that's the turning machine there. Still we have to bring down for the turning machine. Okay, here now turning machine, where's that? Turning machine 4 to job. Turning machine 4 to job is 2 days. So we are adding 2 days and we are getting 2 here. These 2 we are writing here. Then third job under the turning machine 5 days it takes. 2 plus 5, 7 days. 7 comes here. Now first job how much it takes? 3 days it takes. 7 plus 3, 10. Okay. Then 10 comes here. Then in the sixth job takes 11 days. So 10 plus 11, 21. Now 21 is the starting time. Second 12 takes 33. Now fifth job 33 plus 9, 42. Okay. So this is the way we can calculate the total time for the in time, out time for the turning machine. Okay. Now similarly threading machine, instead of 0 here, after 2 days only it can start 2 here, then fourth job 6 days comes, 2 plus 6, 8, then 8 starting time, third one 4, 8 plus 4, 12, okay, then 12 comes here, 12 plus 8, 20, then 20 here, but look at this, to finish this 21 days comes, but here it finishes in 20 days itself, therefore on 21 only it can start, okay, then 22 comes here because 6 job 1 day takes, therefore we get that 1 day 22, then here 33 days it takes, so it has to wait some days to come over from here to here, okay, so that 11 days I think so, 11 days it takes, that's what is coming here, and you will get that one. And similarly for curling time, the 8 days he has to stop, then 20 days, then add this, and then add the time, third time, 9 days, add with 9. If you do like this, you will get this 77 is the first final time, and this is called total elapsed time, total elapsed time, okay. And now we are looking at the ideal time, where the first machine 2 days is waiting, and then second machine, third machine 8 days is waiting, but first machine is not waiting any days, okay. And here 9 days, which one? 9 days, no, it is a 3, 0, it has to come here, it has to come 0 here, okay, here it is 0, not 9 days, right, now, like that. Now, look at this, 11 days comes here, because 33, 22, 11 days it has to wait. So now, what we see here, 77 minus 42, 35 days it has to wait, 77 minus 45, and then 32 hours, you add this, you get 46 days, and here 8 days. Therefore, total elapsed time is 77 days, and ideal time for the first machine is 35 hours, and then for the second machine it is 46 days, and third machine it is 8 days. Thus, we can finish our problem. So, thank you very much for listening.